This is a Precalculus lesson 9.1 on basic combinatorics. Hopefully by the end of this lesson you'll be able to use the multiplication principle of counting permutations or combinations to count the number of ways that a task can be done. I decided to make this video since a lot of students had missed the lesson in class, and there were a number of questions still about these different topics. What I'd like to start with is simply talking about the ways of counting that I'll start with the way you've used in the past, which is simply to list out all the options. So if I were to ask you to arrange three objects in order, so how many three-letter codes can be formed using, let's just say, A, B, and C, what you originally would have done is you would have just listed out all the options in some logical sequence. And when you're dealing with letters, the most logical is generally alphabetical order. So you would list A, B, C, keep the first letter the same, and then go alphabetically greater at the second letter and just list what's left for the third. And then continue that pattern. Students really like it when I get to cab here for some reason. That's a real popular one. So you can see that there would be 6 options. 6 options. That's a 6, if you're wondering. So that's one way. Obviously, if you get to more letters or the bigger the group is, the longer it would take to list them out. But you could also use a tree diagram. How a tree diagram works is you start by, on the first column, you list your first option. Your first option, we could do A, we could do B, or we could do C. Then your second option, from A, you list your second option, would be either B or C. Here it'd be either A or C, and here it'd be either A or B. And then you'd list your third option. And now, from here you'd say C, B, C, A, B, and A, and then you count this last row to see how many options you have. It's the same concept. You actually list them out in the same order as you did in the first grouping. It's just a way to organize them to make sure you include every option that you have. They're also very helpful when we get into some probability type questions. So then from there we can get to our multiplication principle of counting. The multiplication principle of counting gives us another way of figuring out how many different combinations we could have, or how many different three-letter codes could be formed. And what the multiplication principle says is basically you take however many options you have at each stage and multiply them together. So for instance, if I want a three-letter option and I have 3 letters to choose from, well, the way I take a placeholder and I ask myself, well, how many options do I have to put in the first spot? I would have 3 in this case. And then I'd ask, well, how many options do I have left after I chose one for that first spot? I'd have 2. Then after I chose for those first 2 spots, how many would I have left? 1. Multiply them together, and you get that answer of 6 again. That's the concept. If you have a certain number of options for each spot, you multiply them together to see the total number of options you would have. A classic example of using this counting principle, or this multiplication principle, is your license plate problem. There's a lot of different ways of asking this, but in general, if you had a license plate that had 4 numbers, or 4 letters, excuse me, followed by 3 numbers. Find the number of different license plates that could be formed if there's no restriction on the letters or digits that can be used, which means you could repeat, you could use any of the letters, any of the numbers. Well, you just take the number of options you have and for each spot and multiply them together. There's 26 letters, so you would take 26 for the first option, and then since you can repeat, you'd have 26 options here, 26 options here, 26 options here, and then the last 3 are numbers. Well, how many digits are there? There's 10, 0 through 9. So you multiply times 10, times 10, times 10. That answer would be how many different license plates you could form under that scenario. And then if you want that answer, it's a lot. You got 456,976,000 different possible license plates. Moving on here, permutations of an n set. Basically what that means is how many different ways are there to rearrange n number of options, or n number of things we're looking at. Like there would be 4, 5. That's the n we're talking about. How many different ways are there to rearrange n number of different things if you took all of them and the order did matter? Well, that would be n factorial. Kind of a side note here, what does n factorial mean? Well, this, what you used to know as an exclamation point or exclamation mark, it actually means factorial. Factorial. So if I said 5 factorial, that would be the same as saying 5 times 4 times 3 times 2 times 1. So that would equal 120. That's what 5 factorial means. Just some things to help you so you don't have to always type all that into your calculator or find the factorial button on your calculator under math and under the probability subheading. What you can do, if you had something like 10 factorial divided by 8 factorial, we'll realize 10 factorial is the same as 10 times 9 times 8 times 7 times 6, 5. Oh, it's not going to help there. That's a 5. Times 4 times 3 times 2 times 1, all over 8 times 7 times 6 times 5. Come on, 5, you can do it. Times 4 times 3 times 2 times 1. And the point is, you should realize those are going to cancel out. And it's just going to be the same as 10 times 9, which you should know without typing anything in, is 90. Another way to look at it is it equals 10 times 9 times 8 factorial divided by 8 factorial equals 10 times 9, which is 90. Realize, as a side note here, 0 factorial we have set equal to 1, and basically it equals 1 so that we can do a lot of things with factorials and not have to worry about dividing by 0, but that'll come into play a little later on. So if we tune back into what we were talking about before, getting back to permutations, if we wanted to know how many different permutations of the letters that make up the word computer, I would simply say 8 factorial. And 8 factorial, you know, is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which would be 40,320. And I'm fine by doing that because every letter in computer is different. Well, if you have a different word where letters repeat, like in butterfly, then you have to do a little bit more. You have to use this distinguishable permutation formula, which is simply jump back. You're going to take the number of letters you have, factorial. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial. But then you have to divide by how many times any numbers repeat, factorial. So we've got 2 t's, which means I have to divide by 2 factorial. No other letters repeat, so that's going to give me the number of ways to rearrange all the letters in the word but. If I had more letters that repeated, I would do the same type of thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 9 letters here. I'd do 9 factorial divided by, let's see, B's, 1, 2, there's 3 B's, so I need a 3 factorial. U, there's just 1, so it'd be like putting a 1 factorial on the bottom of that just equals 1, so I don't have to do that. Same with that, same with that. There's 3 E's also, so now I have to multiply by 3 factorial again on the bottom. I will warn you to be careful when you're doing this that you don't accidentally just divide by the first factorial and then end up multiplying by the second. Make sure you use parentheses, otherwise you'll end up getting the wrong answer. Or you might end up getting the wrong answer, depending on the situation. From there, we can jump to permutations when you have n objects taken r at a time. This is the notation we use for that. And basically, it's for using n objects to fill r blanks in order. So we use this formula when order matters. That's the key. When order matters. Another notation you might see is P parenthesis N R. It's very common. It means the same thing. This is when order matters. So, for instance, here's an example. 16 actors answered a casting call to try out for roles as dwarfs in the production of Snow White and the Seven Dwarfs. In how many different ways can the director cast the 7 roles? In this case, the order would matter. Say, the director would need to how many? So, we need 7 actors. The director would need 7 actors, and he would need to assign each of them a specific role. So, Sleepy, Dopey, Doc, and so on. 1, 2, 3, 4, 5, 6, 7. Let's see, we got Sleepy, Dopey, Doc, Sneezy, Bashful, Ornery, Math, Nerd. That was probably Doc. Anyway, so those are 7 specific roles. That means the order matters in which he casts them, or he's assigning each of them a specific role, which means we want to use a permutation, which would be 16 permutations of 7 actors. We could also write it this way: 16, comma, 7. That's a 7, by the way, which would be the same as 16 factorial divided by 16 minus 7 factorial. Which is a big number. So you're going to get something like 5, 7, 6, 5, 7, 600. So 57 billion plus. It's a lot of different ways to do it. But that would be different than a combination. This combination, it's different now. A combination of n objects taken r at a time again is denoted in this way. We also can use C, N, R. Also, if you saw n, let me clean that up a little bit. If you saw simply n, r like this, that also means a combination. We read this as saying n choose r. That's where the order doesn't matter. So say in the last example, the actor or the director had to choose 7 people just to be choir members, where the choir members did not have a specific role. Well, that question then becomes, instead of what we just did, now they aren't assigned each a specific role, they're just choir members. So we would want 16 choose 7. Or we could write it in this form. That'd be the same as this. Not quite like that. Which would be 16 factorial divided by 7. This is really going haywire. Divided by 7 factorial times 16 minus 7 factorial. And that answer would be substantially less because you're dividing by more. You know, the specific roles in the first one really increase the number of possibilities. 11,440 different combinations of actors could have been cast for this choir job. So from there, it really becomes the question for you is not how to plug in the numbers into the equations, but basically which equation should I use, or what situation am I dealing with. So that's what is going to be hardest for you to figure out. And it's all about whether the order matters, not in which you pick things. So in this case, a president, vice president, and secretary are chosen from a 25-member NHS club. Well, in that case, you have a specific role assigned, which means we want it to be a permutation. You're picking 3 people for 3 specific jobs. Number 2, a cook chooses 5 potatoes from a bag of 12. Well, how many ways could you do that? Well, you've got 12. It doesn't matter what order you pick the potatoes in. You just need to get 5 potatoes. So that's a combination. Teacher makes a seating chart of 22 students in a class of 30 desks. Well, that's a permutation because each student's going to be different. So therefore, their position is definitely going to matter. So I'd need to choose the 22 students in the desk that they go in. So 30, and you're choosing 22, but the order in which you pick them would matter. If you picked, like, say, the first desk that you pick is going to be the first student on your chart, well, that would put the student in some different order, and the different order affects the seating chart. And you all know that when you're placed in different desks next to different people, you have a different seating chart. Not too complex there. The last piece of information you need is a formula for counting subsets of an n set. There are 2 to the n subsets of a set with n objects. That includes the empty set where you don't pick any, and includes the entire set where you pick everything. This is a classic problem where you could order pizza from a pizza place, and you wonder how many different pizzas you could order. Well, if there's 5 toppings, there's 2 to the 5th number of pizzas you could order. If there was 16 toppings, well, there's 2 to the 16th number of toppings you could order. That includes not ordering any topping. That pizza would be horrible. It includes any 1-topping pizza, 2-topping, 3-topping, 4-topping. It includes all of them. So that's what you'd use in those scenarios. Just wanted to mention a couple little more challenging type problems, or where there's more to it. Let's say that there's a theatrical group that needs to select 2 musicals and 3 dramas, and they have a total of 11 musicals to choose from and 8 dramas to choose from. Well, you want to know how many different ways the theatrical group can select 2 musicals and 3 dramas from 11 musicals and 8 dramas. Well, it's just asking how many ways there are to select, or how many different combinations we could have of 2 musicals and 3 dramas. It's not asking how many different ways could you pick them and in what different orders could you pick them. So in this case, what you'd need to do is you'd need to choose 11, or choose 2 of the 11, and you'd need to choose, oh, sorry about that, I wrote that backwards. You need to, from the 11, choose 2, and from the 8, choose 3. And then what that means is, now I'm picking 2 from the 11, I'm picking 3 from the 8 now. Do I multiply? Do I add? What do I do? Well, you're going to need to multiply, because any answer you get from this first one can go with any answer you get from this second part. So therefore you have to multiply and get your answer. Another type of problem you might have would be, let's say there are 6 men and actually let's do there are 6 women and 5 men trying to fill 4 cashier positions. And let's say that we want to know how many ways the positions can be filled if at least 1 man is hired. Well, if at least 1 man is hired, that means that you could hire 1 man, you could hire 2 men, you could hire 3 men, or you could hire all 4 men. So whenever you have an or situation like this, you need to figure out how many ways you could hire 1 man, plus how many ways you could hire 2, 3, or hire 2, 3, 4. And then it's the same type of problem as last time. You'd have 5 men to choose from, and you have to choose 1. Times, then the rest would have to be the women. So there'd be 6 women to choose from, and you have to pick 3 of them. And then there'd be 5 men, you have to choose 2. Times there'd still be 6 women, but you'd only have to choose 2 now. And so on. Choose 3 men, then you only get to choose 1 woman. And then the last option would be how many ways, I don't really have to write this, but if there were, oh yeah, I do have to write that. If there were 5 and you chose 4, well then there'd be 6 women and you're choosing 0 of them. Well, how many ways are there to choose 0? Just 1. And then you'd have to add all that up to get your answer. I believe if you did that correctly, you should get 315. That should help you out. Good luck, and make sure you're asking questions in class.